Ladies and gentlemen, my dear students, welcome to this example. This is a follow-up example from the previous work on binomial distribution, and I thought perhaps I should give an extra example that will help you to master the concepts involved in binomial distribution. Right, so I think for you to go through this video, you need also to go through first of all, you need to go through the previous one where we just introduced the binomial distribution and we gave the conditions under which it is used and we gave a simple example. Now this is another example. So the example that we are given here, we are told that there in a particular community, they are expecting mothers, and we are told that in that particular community, all the expecting mothers will have a 60% chance of them giving birth to a baby girl. So, and in that community, we are told that there are 8 expecting mothers chosen from the community to determine the following probabilities. So I want you to appreciate that this is a binomial, distribution case. If we choose any expecting mother, it's either the mother will give a birth to a boy or to a girl. So I want you to make an assumption here. There is no issue of giving to a baby who is neither a boy nor a girl. We don't want to, we assume that it's just a normal scenario. It's either a baby, it's a boy, and it's a girl. So every time we choose a mother, it means that is a single trial. So the mother can either give birth to a boy or to a girl. So because we are doing this trial 8 times, you see, when we say we are choosing 8 mothers, what is the probability that none will give birth to a girl? All of them will give birth to a boy. I want you to take note of this change. 60% chance giving birth to a baby girl. So 60% is for a girl. So for a boy, the success is now 40% when we refer to a boy. That is very, very important. At least 5 of them will give birth to a baby girl. So we are going to answer all these questions in the following slides, and I will be explaining what is actually happening. So let the random variable x, this is very, very important. We start by defining what our random variable x is. The random variable x be the number of girls from the expecting mothers. So those mothers, how many girls? So when we say probability x equal to 0, we are simply saying, when we say probability x is equal to 0, for example, probability of x equal to 0, probability x equal to 0, what we are simply doing here is to say number of girls. There is no number of girls. So what is the probability that all the expected mothers will just give birth to boys, not no girl? So none will give birth to a girl. Remember the probability distribution function that I did show you from the previous video. So it's saying probability x equal to r is out of n, choose r, p, where p is the probability of success to the power r, multiplied by q to the power n minus r. So x follows a binomial 8 times. Probability of success is 0.6, and here I've indicated what my q is. Remember, p plus q is always equal to 1. So once I'm given q, so I can easily get q. Now, probability x equal to 0, because the question is saying none will give birth to a girl. So x will be equal to 0, and I want you to take note that our r from the probability distribution function is now 0. So we just put in the values in the formula. So 8 choose 0, p to the power r, which is 0, q to the power n minus r, which is 8 minus 0. So that will be this. So our answer is this one. And I want you to take note of what this answer is showing us. basically. It is very, very important for us to understand. You see, if the probability of an event is approaching almost zero, it means that event is a rare event. And it makes absolute sense because we are told that there is a 60% chance that the mothers in a particular community who are expecting will always give birth to a girl. So the chance of getting a girl is very high. But out of 8 expecting mothers, now you are told that none of those will give birth to a girl. So you can see the probability is very small. It's actually closer to zero. This probability is very small because of the nature of the information that is given. Now let's move. All of them will give birth to boys. I want you to take note that our P has changed. Remember, P for boys is actually equal to 0.0.4. Sorry, my writing is not that good. 0.4, because P for girls is 0.6. So the success here, because we are now referring, and I want you to check even the X, I've tried to show that it's X for boys. Remember how we defined the number of girls. So this XB is a variable showing the number of boys. So probability that X, the number of boys will be 8. We just use the information now, the new information where we've changed our P, and you can see our P. So this will give us this answer. Now, I have given a note here, which is very, very important. Take note that the probability no boy out of 8 is the same as probability all. What did I say here? No. I think there is a mistake here. Probability no girl. I meant this to be probability no girl. Probability no girl. Please forgive me here. Probability no girl out of 8 is equal to probability all boys. So if all the 8 mothers don't give birth to any girl, it simply means that all of them will give birth to boys. And this makes a lot of sense. That is why the answer that we got from the previous, that is probability no girl, we got this one, is the same as probability all are boys, and which is this one. Now, at least 5 of them will give birth to baby girl. So we return back to this one. Now, probability X at least means from 5 and above. If I say at least 5, it means start from 5 going up. At most means start from, at most 5 means from 5 going down. This is very, very important. At least 5 from 5 going up, at most 5 from 5 going down. So probability X is greater or equal to 5 is the same as probability we are starting from 5, or you see, or we put plus in probability X equal to 6 or 7 or 8. We are ending at 8 because there are 8 mothers. So at least 5, it's either X will be equal to 5, or will get 5 girls or 6 girls or 7 girls or 8. That is at least 5. So with that in mind, you see for this one, we just expand it to become this one. I want you to take note here. Expand it to become this one. This one, expand it to become this one. For 6, so for 7, take note, just go and check from the probability distribution that this is proper expansion. So when you do this, you just use your calculator, you plug in this, you can put brackets, then you say 8 choose 5, this directly 0.6 to the power 5, 0.4 to the power 3, plus, then you put another bracket, you plug this, plus you put another bracket, and you see that your answer is this one. So which is 0.4, that one. Now, at most 3 will give birth to boys. Now, I want you to see how things have changed, but here, I think there should be a small b here because we are now referring to boys so that we are consistent with what we are doing. At most, it means from 3 and below. So this is probability X is less than 3, which is from 0, 1, 2, and 3. This is very, very important. We do the same. You can see the expansions here. the expansions corresponding to these ones, and then you plug into your calculator, you get that one. Then the last one, what is the expected number of boys from this scenario? So these are the two formulas that I've added now, which I want you to take note of. Expectation for a binomial, if we have x that is approximately binomial, if we have x that is approximately binomial NP, where n is the number of trials and p is the probability of success. So the probability expectation of x is given by n times p. Variance of x is npq. And since variance is npq, you can tell the standard deviation and the other things. We know that from the previous work that we've done. So the expectation, what is the expected number of boys, is simply out of 8, we multiply by the corresponding p, and we get 3 point this. But this 3.2, since it's discrete, we have to approximate it to exactly 3, because we cannot have 3.2 boys. It doesn't make sense. So thank you very much, ladies and gentlemen. I hope this video will help you to master the concept of binomial distribution. In the next segment, I'll give you an introduction to Poisson and a couple of examples. Thank you very much. Have a blessed day.